Find the values of k such that 2x squared minus kx plus 2 is equal to 0 has a. 2 equal roots, b. 2 distinct roots, and c. no real roots. Now, to determine the nature of the roots for a quadratic, you need to use what's known as a discriminant. Now, this is part of the quadratic formula, which is b squared minus 4ac, and we use this symbol to stand for discriminant. Because if this is equal to 0, then you get what's known as 2 equal roots. If it is bigger than 0, then you get what's known as 2 distinct roots, and if it's negative, you get no real roots. So let's just have a look at that. So if you take 2x squared minus kx plus 2 is equal to 0, and compare it with ax squared plus bx plus c is equal to 0, then we can see clearly that a is equal to 2, b is equal to minus k, and c is equal to 2. Now, for equal roots, b squared minus 4ac is equal to 0. So putting the values in, we get minus k squared minus 4 times 2 times 2, which is going to give me that k squared minus 16 is equal to 0. Which means that k plus 4 and k minus 4 is equal to 0, which means that k is going to be equal to minus 4 or 4. So if we now look at an autograph file that I've made, this is y is equal to 2x squared minus kx plus 2, where k is equal to 0. If we change the values of k, you can see when k is equal to 4, we get what's known as 2 equal roots, i.e. the curve just touches the axis, okay? And when we want to go to minus 4, again we get another set of values where the curve just touches the axis, the original quadratic. So, there we can see the first case where k is equal to minus 4, and here we can see the second case where k is equal to 4. Now, if we want 2 distinct roots, then the discriminant b squared minus 4ac must be greater than 0. So we go back to our expression for k, which is k minus 16 is greater than 0, which gives k plus 4, k minus 4 is greater than 0. If we look at the graph of k squared minus 16, which will look like that, okay, where is this graph greater than 0? Which is greater than 0 here and here, so that will be less than minus 4 or greater than 4. So that for those values of k, the original quadratic will have what's known as 2 distinct roots. If we go to this, if we make our values less, you can see here we have 2 roots on the original quadratic. Okay, and this value is minus 6, which is less than minus 4. If we go the other way very quickly, again, here is k is 5, we will see we get 2 equal roots again. So in the final case where we want no, so the answers will be k is minus 4, k is greater than 4. For no real roots, b squared minus 4ac is less than 0, so again we'll look at k squared minus 16 is less than 0. Okay, k plus 4, k minus 4 is less than 0, so we'll look at the graph for that, okay, and we want to know where k plus 4, k minus 4 is less than 0. That's going to be from here. Okay, we can see the graph is quite clearly negative here, so that's going to give must be between minus 4 and 4. If we go to our autograph file again, if we look at between 4, you see we get no roots on the original quadratic. See, all these values here we have no roots. Okay, at 4 we do, here we have no roots. Okay.